Okay. So let me share my screen first.
बिल्कुल देखिए ऐसा ना हो जाए कि कहीं बात और मिला हो दोनों कहाँ से चले जाए उठ के हो गया पूरा चुनतरा जिंदाबाद बोल के
So I hope my screen is visible to you. কি হয়েছে? আমি ক্লাসে আছি। So hello everyone. So this is the assignment for week 1 for the course of analog communication. Okay. Am I audible right now? Yeah. So let us start from the first question. The question number 1 says the power of an energy signal is always 0.
डिटेल डायग्राम और नीचे आएगा तो देखें बस क्या ये ऐसा डायग्राम दे या फिर सिंपल डायग्राम दे
So option 1 is we have to comment whether it is true or it is false. So basically if I think about the power of an energy signal, this is always to be 0. This is due to the fact that one energy signal is not periodic sort of thing. So whenever we are doing some sort of calculation, there is a term 1 by t, that is a time period, and we divide it by t to the power minus 2 to the power t tends to infinite. So basically we say t is the time period of that signal. So basically we take the summation over this over some period. So basically as this t goes to infinite, something by infinite, that comes nearly to 0. So basically if that is the energy signal, it is not periodic. The right answer is the power of an energy signal is always 0. So the correct option is true, option A. Is it okay with everyone? Okay. Let's move to the second question. The second question says, energy signal is always of finite duration. And we need to comment whether it is true or false. Yeah, someone commented false, that is the right option. This is because of the same reason. So if a signal is energy signal, it is mostly like not going to repeat itself. It's slightly going to converge at some time. This is because this should be a finite. I mean this condition. So this condition will be followed and it will converge to some point, but it is not periodic. So basically energy signal is always of finite duration. So we can say it will be of some finite duration. It will be to converge to zero after some sort of time. So that is the reason it is always of finite duration. But if it was a power signal, then it should have been a periodic signal. Okay. Now let us move to the third question. Question number 3. Question number 3 says power signal can also be
And
of
also
finite duration.
be of finite.
So basically power signal, yeah, that is false. So if a signal is a power signal, it is going to be periodic with some time period t. So that is the reason power signal has, if I calculate the power of that signal, that says that same term limit t tends to some period by 1 by t, that is not infinite in this case because it is periodic at this case. So after some period it is going to repeat itself. So we calculate the energy within that interval, that is the power of that signal. So power signal is always a periodic signal and it is not going to be finite because it will repeat it until the infinite in this way. So that is the reason a power signal cannot be of finite duration. So it is a false. Someone raised a queue. Can you, what is the question? Okay. The next question is question number 4 is, let me write the question first. It is a big question. If the Fourier series, so the Fourier series of the signal is always known to us in the representation of the Fourier signal series. So I'm going to write that representation once again for the clarity. Some signal xt, this is a periodic signal, and this signal has a Fourier series representation. So that is this term is a DC term, and the harmonics I am writing, this is cos 2 pi nt by t, and the harmonics belongs into 1 to infinite. Similarly, it will have a term corresponding to the sine term, that means with a phase shift of 90 degree, t by t, and this is also 1 to infinite. So this is the Fourier series representation that we all know. So basically there is another representation in the exponential form, so that can also be written as n is equal to minus infinite to infinite Cn exponential minus 2 pi jnt by t, so that two are the same representation. So there are some conditions that we need to write. A, that coefficient an is equal to Cn plus C minus n, and B of n equal to imaginary part into C of minus n minus C of n. Second option, similarly an is equal to C of n plus C of minus n, and B of n is equal to J of Cn minus C of minus n. Option C is an equal to C of n plus J of C minus n, and B of n is equal to C of n minus C of minus n. Another option is option D. An is equal to Cn plus J of C minus n, and Bn is equal to J of Cn minus C of minus n. So which of the one will be correct statement from this, given the representation of the signal like this? Any comment? Okay, just take this equation, x of t equal to n equal to minus infinite to infinite C of n exponential of minus 2 pi jnt by t. Okay, so basically let us put the fact n, replace a n by minus n. So the coefficient that belongs to an, so let us take the term that will come for c minus n first. That will contain the term cos of 2 pi j nt by t and minus sine of 2 pi j nt by t. So basically this, wait a minute, so basically if we replace n by this minus n and we just compare this equation with this equation, we can find an. And also if I break this exponential series, we know exponential of minus some j theta is equal to cos theta minus j sin theta. If we put this equation in this equation and then it is going to into n is equal to minus infinite to plus infinite, here it goes n is equal to 1 to infinite only. So that is the reason we can just replace minus n with minus n in this equation. And if we replace and compare the cn coefficients with the an and bn, you will get the answer an is equal to cn plus c minus n, and correspondingly you will get bn is equal to j of c of minus n minus c of n, because this term there can be a c of n and minus j of cn, similarly a sine term will be there. So basically if we calculate this coefficient, compare this equation with this equation, this an terms, we'll get this answer. Wait a minute. And this will be option A. So the correct option of this question will be option A. Now let us move to the next question. The next question says, if the Fourier series of the signal is given by x of t equal to a0, the same Fourier series representation here, n equal to 1 to infinite an cos 2 pi n by t, the cos harmonics, and also plus the another part. Now the question is, for any half wave symmetric signal xt, what is half wave symmetric means? This means x of t is, if I shift the signal by a time period of t by 2, so x of t is the just negative portion of this. So basically there is a signal, we shift the signal by half of the time period, and then we just take what is the value of this half of time period, negative of that thing is the first half in the short. So the question is, there could be the coefficients an, and let me write in the new box. So there is a half wave symmetric signal xt, and the question is, which of the following quantity will be 0? So we have to find which of the Fourier series coefficients are 0. So there are options. The first option is both an and b2n. Second option is both a2n and bn. Third option is a2n and b2n. So let us solve this question. So what is the coefficient an? An equal to, we know this representation of an, 0 to t x of t cos 2 pi f n t dt. So we can write this as this 2 by t, and as it is 0 to t, we can divide it into two intervals. First interval is 0 to t by t, and then write the same, because integration follows linear property. So we can divide it into two intervals easily, and this is a continuous function also. If, sorry, this is looking like I'm taking the subscript of it, t dt plus t by 2 to t x of t cos 2 pi f n t dt. So basically I have done, like, I just divided it from 0 to t to 0 to t by 2 and t by 2 to t, just in two intervals. This is the first step. Now let take t some variable that are time, and it replace it by z minus t by 2. So if we do that and replace this in this equation, but we are only going to replace in this first term, not in the second term. Not in the second term. So the first term if we replace, the coefficient a of n will be 2 by t. So basically here this is z minus t by 2, so this limit will be changed also. So after changing the limit, it will be like t by 2 to t to x of t cos of n pi minus 2 pi fnt. This happened just by replacing this with this. Like you can take here this t is z, sorry, so better clarification, I can write it as z dz z z, that sort of thing, but it does not change the how the integration is going to happen. So that is the reason I am just, for the clarity, I am just using it as t. Like let me say it was like with z, and again I replace z equal to t, some new variable t. So that is the because that will be helpful to understand the equation. And there will be another part like this, t by 2 to t, it is the same term that was written here, cos of 2 pi fn t dt. So this is the simplification for an. Now just think, if a2n happens here, this n will be replaced by 2n, every n will be replaced here by 2n, but the catch is it will be 2n pi at that moment. So it will happen 2n pi, there will be a 2, but we can see from the first point that x of t is equal to x of minus of x of t minus t by 2. So this implies these two terms will cancel out each other. So from this we can say a2n equal to 0. Similarly, we can derive b of 2n equal to 0. So the question was about which of the following two terms will be 0. So we saw that a2n equal to 0 from this equation, and similarly we can find that b of 2n equal to 0 too. So correct option will be option C. This will be the correct option. Is it okay? And one more shot, this was x of t has been, we have taken this t minus this remains x of t because of the fact that this equation holds. in this equation. I forgot to mention why I have used this equation. So if this equation holds, then if we replace this t is equal to z minus t by 2, these two signal remains the same. Now let us move to the next question. So next signal, we have given a signal, we have provided with a signal as signal xt. So we have to find out whether the signal is an energy signal or a power signal. And also, if it is a energy signal, then what is the energy? And also, if it is a power signal, what is the actual power of that signal? So what is the signal? The signal is x of t equal to exponential of minus 80 for t greater than equal to 0 and 0 otherwise. So from the question is whether the signal is a energy signal or a power signal. So the main fundamental thing is we can observe that this signal, if we plot this exponential 80, will look like this. This signal is not periodic signal. Also this is a bounded, that means exponential of minus 80 mod square is less than plus infinite. So this signal is a energy signal. Now we have to calculate what is the energy of this signal. So energy of that signal is xt mod square dt 0 to infinite. So just put xt, this will be exponential minus 8t and it was mod square, so this will be minus 280 and dt, and it is 0 to infinite. Just substitute the values of the integration and you will find that the result is 1 by 2a. So the signal final conclusion is the signal is an energy signal and what is the energy? Mod of xt square 0 to infinite equal to 1 by 2a. This is the energy of the signal. Okay, now move to question number 7. So question number 7 says delta is the usual direct delta function. Now we have four options. The first option is del of omega 1 by 2 pi del f. So these are the four representations, and omega is equal to 2 pi f. This is the angular frequency, this is the frequency in hertz. So we have to say which one is the correct option among all four. So this direct delta function has a property one by mod of a del x. So basically this is the scaling property here. So if we follow this one, so omega is equal to del of 2 pi f, and this will be 1 by 2 pi del of f. So basically this scaling factor works like this. That is the reason the option A is the correct option. It is not option B. Okay. The next question. There is a signal that is x of t is equal to a cos omega 1 t plus theta 1 plus b cos omega 2 t plus theta 2. So basically xt is a signal, that is a periodic signal obviously, with continuous periodic signal in this case, with two cosine terms here. The first term is this, second term is this. The question is, and also given that omega 1 is not equal to omega 2 obviously, otherwise these two functions will could have only a phase difference of theta 1 and theta 2. So there are four options. First option is a plus b square by 2. We have to, okay, I have forgot to write the question. So we have to find out what is the power of this signal xt. That is what we need to find out. So there are four options. First option a plus b by 2. Second is a square plus b square by 2. The third option is a square plus b square plus 2ab cos of theta 1 minus theta 2 by 2. The last option is a square plus b square plus 2ab cos of omega 1 minus omega 2 by 2. So the four options are given and the signal is given like this. So what is the power of this signal among these four options? Yes, the correct option is option B. So let me derive it also. So how the power is getting calculated? This is limit t tends to infinite 1 by t 0 to t cos of omega t plus theta dt. So this term is always 0 if t is the time period. This is because if you draw a cos function, suppose the cos functions looks like this, and if you integrate over this whole time period t, the positive part will cancel out the negative part. So if I integrate over this region, it will give me a value 0. So this is the thing that will be used later to derive this equation, the equations used for this question. So first is limit t tends to infinite 1 by t cos square omega t plus theta dt. This I can write as, let me write it, t tends to infinite, 1 by 2t, 0 to t, just dividing the cos term with the cos formula, theta dt, and this is equal to 1 by 2. Again, one t plus theta 1 into cos of, so I am deriving these equations first. I have stated the first thing. The next thing I have calculated is this thing, and now I am calculating this thing. So all these three will be required to calculate the power, actual power of that signal. So obviously dt, this is another term, integration term, that will be required later. So this is equal to limit t tends to infinite, 1 by 2t, 0 to t, cos of omega 1t plus theta 1 dt plus limit t tends to infinite, and this will be required, like this part and this part. So what is the omega 1 hat? Let me write it. This multiplication factor has been divided in this type. So omega 1 is equal to omega 1 plus omega 2, and omega 2 hat is equal to omega 1 minus omega 2. So just this multiplication, cos of AB is equal to cos of A plus B by 2, cos of A minus B by 2, that formula has been used here. And theta 1 hat is equal to theta 1 plus theta 2, and theta 2 hat is equal to theta 1 minus theta 2. Just if this formula has been used, cos of A and cos of B. So this term is A, this term is B, and then if we add these things up, this A plus B, A minus B, there is a formula of cos of the trigonometry equations. So just note, this term and this term is to 0 to t, and first we have derived that this term is equal to 0 if the integration is over 0 to t, no matter what frequency it is. So that is the reason I can write this whole summation product, this multiplication that has been derived in the summation products over 0 to t is equal to 0. So this term has a value of 0 also. So limit of t tends to infinite, 1 by t, 0 to t, x square of t dt. This is the power of the signal, and if I replace the signal with the actual xt, this is the xt, and we take the xt square, we can expand this equation as follows. That is simple formula, a square plus 2ab plus b square. omega 1t plus theta 1, this is the a square term, and also there is a b square term, b square cos square omega 2t plus theta 2, and there is a 2ab term, so that is 2ab cos of omega 1t plus theta 1 into cos of omega 2t plus theta 2 dt. So the whole term is in this integration. So this is a square, b square, and this is a 2ab term. Again, this part will be equal to 0. Why? Because we have derived this already. This term is equivalent to 0 if we follow these equations from this condition. So this term will cancel out, it will not remain there. So we have to just calculate it over 0 to t, this term and this term. And again, we have also calculated what is the value of this term, cos square omega t plus theta. A similar expression is here, cos square omega 1t plus theta. So the result was half here. It is multiplied a factor a square. So this term will be a square by 2 plus a similar term b square by 2. So the right option is a square plus b square by 2, option B. Is it okay? Now just consider the same question. I have the same signal and just with one condition. It was written that omega 1 not equal to omega 2. But what happens when omega 1 equal to omega 2? What will be the power of the same signal? So if omega 1 equal to omega 2, in this case, this term we have to check once again what happens here. We cannot simplify it like this because omega 1 equal to omega 2. They just have a phase difference in this case, not a frequency difference. And in such scenario, with the condition omega 1 equal to omega 2, if we do that, the equation that will come is it will be equal to cos of theta 1 minus theta 2. So basically in the previous question, the whole term was going to be 0 if omega 1 not equal to omega 2. But if omega 1 equal to omega 2, only this term still remains. It does not become 0, not equal to 0. So this term will be reflected in this equation too. So basically what will happen, this term will still remain, it will not cancel out, and the value of the term will still remain. So this a square by 2 term will remain, and from this b square plus b square by 2 term, it will also remain there. So this comes from this, and also this term will also be here. What will be the value of this term? Half cos theta 1 minus theta 2. So this will be half cos theta 1 minus theta 2, and these two scalar factors. So there will be a term 2ab. So in this scenario, the right option will be option C. A square term will become, b square term will also remain, and this term, as it does not become 0 because of omega 1 and omega 2 are the same frequency, and these two have only a phase difference here of theta 1 and theta 2, not any frequency deviation. So at that time this term will remain here, and the power will be affected by this phase difference. Okay. Let us move to the last question of today. So question number 10 says, let x of t is a periodic signal. With a time period of t, and the signal is defined over a interval of minus t by 2 to t by 2. And what is the signal? So it is 0 if it is minus 8t is greater than this, and it is 1 by 280 if it is within this interval. And also it is 0 if 80 is less than equal to t by 2. The question is, what is the Fourier series coefficient, particular Fourier series coefficients here? which of the following is true? So first is a0 is 1 by 2t a of n equal to 0 and b of n is equal to sine pi na by 2a t pi n. Option B is a0 is equal to 1 by t, an is equal to sine 2 pi na by at pi n, and bn equal to 0. C is a0 is equal to sine of pi a by 2t, an equal to 0, and bn sine of pi na by 2a t pi n. Option D is a0 equal to 1 by t, an equal to 0, and bn equal to sine of 2 pi na by at pi n. So basically we have to find what is a0, an and bn. So let's derive. So a0, the coefficient a0 is equal to
हम्म
1 by t
मतलब बड़ा डायग्राम नहीं करना है छोटा
minus
डायग्राम बना के
t by 2 to t by 2 x sub t dt. So this actually means what is the DC value, I mean what is the mean value or average value of a signal, what is the average, if I average out the signal within this interval, what will be the value. So that is the DC coefficient here, sort of thing. So this is equal to, just substitute the value, and this signal only varies within the interval minus 80 to 80 as per this equation. It only has value within this interval. So this integration becomes minus 80 to 80
इसको फिर हम लोग अलग अलग कलर असाइन करेंगे कि किसको
as it was
स्टीरियो में किसको जीपीयू में सॉरी हार्डवेयर में
280.
बात समझ में आ
So
रहा है तुमने देखो कंप्यूटर लिखा हुआ
just put the value
पहले वाला
280
ऊपर पहला वाला वो
is
है
equal to
सेवेंटी वाला है ना
1 by
उसको उसको
t.
भी ऐड कर दो उसको ऐड
Similarly,
करो उधर इसको डाल दो इसको
n
इसको
equal to
तो ये
2 by t minus t by 2 t
ये
by
है
2
मेरे पास
x sub t
जो तुम्हें भेजा उसी वाला
cos
थोड़ा
2
है
pi n t
उसी
by
का
t
बस एक ब्लॉक एक्स्ट्रा ऐड
dt,
किया उसमें कुछ नाम लिख दिया
and it is 2 by t minus t by 2
प्रेडिक्शन
to t by 2
ट्रांसफॉर्म
1 by 280
मेरे को भेज दूँ क्या फोटो
cos 2 pi n t by t dt. And if I solve this integration, so this, sorry, this will, limit will be changed here also, so it will be 80 to minus 80. This value will be equal to sine of 2 pi na by is it right now the limit change?
ये कॉल सुन एंड में कहाँ कॉल करना पोस्ट पर
Yes,
शुरू होके इंट्रो पे इनकोड
and
में
this
लास्ट में
is
लास्ट में क्या
80
कॉल किया
pi n.
इंट्रो पे कोड उसके बाद डालना पोस्ट
So
पर
this is the coefficient for an. Similarly, let's calculate what is for bn. B of n equal to 2 by t minus t by 2 to t by 2 x of t sine of 2 pi n t by t dt. Similarly, the limits are replaced here. So this is equal to 0. Why this is equal to 0? Because this is a odd function. So even if you put these limits and calculate this, it will come as a 0. But in counter, this was the even function. So basically the reason can be like this. The cos waveform is like this within this interval. But the sine waveform is like this within this interval. So if I do the integration over this region, it will become 0. But if I do the integration over this one, it will not become 0. That is the reason here it becomes sine of 2 pi n by a, such sort of thing, and it is 0 in this region as the function is an odd function. So the correct answer is option B, a01 by t, and an is equal to sine 2 pi n a by at pi n, and bn coefficients are 0. So this was all for today's session. Anybody has any doubt? So basically, if you guys have any extra more doubts in the mid sessions, you can mail me also in this mail ID. Let me write in the chat box. So it is available in the chat box. So thank you. This was all for today's session. We'll meet in the next Sunday.